All right, I see the users are all logged in, which is great. We will continue and kick off this webinar. Good morning, good afternoon, everyone, from wherever you're tuning in, and welcome to this webinar where we're going to be looking at BIM for Civil Infrastructure Development Part 3, focusing on stormwater design. Of course, if you have missed the previous parts of the webinar, they are all uploaded to our Baker Bains YouTube channel. You're more than welcome to go and have a look at them and catch up with the series, as well as a lot of other cool content in different industries. So for those that are joining for the first time, welcome. This will give you some context as to what this webinar series entails. So those that have been following me for a few years right now know that I normally conjure up a scenario. It might not be perfect, but it gets across the principles that you would apply in a civil engineering consulting environment. So this led to a 6-part webinar series focusing on BIM for civil infrastructure. And I thought, hey, the best idea would be to create some sort of a residential development. And the design aspects to be covered is that of site and roads, which we have completed already, stormwater, which is going to be today, sewer, water, and then some visualization. The technologies on the right will be touched on this series, specifically the ones in the red blocks. You've already seen InfluX in action. You've seen Civil 3D and IDAS already for road design, and today we're going to see it for stormwater. What a powerful dynamic duo these two are for civil infrastructure design. And of course, the technologies that are outside of that red box, we would probably touch on them depending on capacity as the series progresses. So I will be your presenter for this series. I am Shoaib Yunus. I'm the BIM technical specialist for civil infrastructure mining here at Baker Bains in South Africa. At Baker Bains, I am involved in numerous projects involving BIM for civil infrastructure, geographic information systems or GIS, common data environments, CDEs, reality capture, scan to BIM, as well as virtual reality and visualization. And of course, if you would like to reach out to me and have a chat, my email address is shoaib@bakerbains.com. So a little bit about, or just a one slider on what I do and the company that I work for. We specialize in various segments across the consulting industry. If you're looking at Scan to BIM, we partner with very cool brands such as Topcon for civil engineering and mining applications, or Leica for interiors and architectural building scanning. Of course, IDAS, which has been the star of the show so far, you're going to see more of it today. It stands for Infrastructure Design Automation Suite, and it really boosts the productivity of Civil 3D manyfold. We also have point cloud geometry extraction technologies, that being ClearEdge 3D, which will analyze your point cloud data and extract CAD elements for you. So instead of you drawing it from scratch, it can save you up to 70 to 75% of time. I've tested it here on our offices in Johannesburg, and in this case, because it wasn't fairly complex in terms of the office layout, it saved me about 90%. So it is a really real game changer in the Scan to BIM workflow. And of course, we have various Autodesk credentials. We do offer classroom as well as virtual or online training. And we are a blended provider, meaning that we partner with CAD Learning. CAD Learning is an online tool or online portal that has about 50+ Autodesk pre-recorded videos, classes that you can attend and learn on the go. More on that at the end of the webinar. So that's just about Baker Bains in a quick snapshot. So today's session, this is what we are going to be covering today. I always start off with a perspective because you need to know why you're doing something instead of just jumping into it. I keep reiterating it so that it makes sense to all those that attend, either those that have followed the series so far or those that are joining in today, which there are quite a few new people, so welcome to you. And then after, we're going to jump directly into the topic at hand, where we're going to look at stormwater design with IDAS and Civil 3D. We're going to see what an amazing tool this is and the resources available to help you upskill and get on the go. And thereafter, I'm going to wrap it up with the closing, look at the key takeaways, how we can help you if you do have any questions during this session, please fire them away into the chat box. I will get to them at the end of the session. So let's start off with the industry perspective. What challenges are normally faced in civil or municipal engineering? So first of all, it's design complexity. If you have a lot of infrastructure on the same site, it can get quite messy, and you need tools to actually help you manage that in a much more efficient way. Thereafter, if you have that ticked, you need to coordinate them successfully, ensuring that all involved is on the same page. I've seen this many times working in a consortium where you have different consultants, and to coordinate between different disciplines, getting the correct positioning, the elevations and so on, it becomes quite challenging. Once you have it, the coordination down, you also need to collaborate, meaning you need an effective synchronized manner in sharing the files so that the latest design data is always available to the team. The answer to this is actually a common data environment using cloud storage, cloud functionality, and so on. And we've seen that increase substantially, especially during COVID and the times that we are currently in. Of course, technology is a big part of anything today. With our rapid urbanization, we need more infrastructure for our growing populations. And without the correct technologies, you're not going to be able to accomplish tasks in an economical and sustainable manner. So technology does play a big part in enabling great civil infrastructure and resilient civil engineering. And last but not least, it's definitely visualization. If you have something like on the right-hand side, which is in my case not really complex, but it's packed with a lot of different infrastructure, and if you are conveying it to people that are non-technical, people that are probably just providing the finance or capital, that don't have any technical or engineering expertise, you need to translate your design in a manner that all on board will understand. And BIM, the byproduct, one of the great byproducts of BIM is actually design visualization. So all of these complexities can be solved with BIM and the correct technologies applied in Cognizant. So now that you understand the challenges that we normally face, especially on a development project, we're now going to jump into the stormwater design part 3. So a quick recap from part 1 and part 2 for those that are joining for the first time today. I've got you covered, so no worries. Right? So this was the project brief that I came up with. Right? It might not be perfect, but it more or less fits the profile of what you would normally get in a consulting office. And we are working and building the plane currently as we are flying it, right? Not the greatest of ideas, but in this scenario or in the situation that we are currently in, I think it's best to learn on the go and to portray it online, especially with our busy schedules and deadlines. So what I have conjured up was, let's say we were appointed as the civil consultants for a project. You can see it is a development in Ballito, KwaZulu-Natal. And what we need to do is provide services for site, road, stormwater, sewer, water, and visualization. Right? And each week or each month when we had our webinars, we tackled different topics. So the first topic was site design, and we had accomplished that quite easily using Civil 3D as well as the amazing template that Devotech has created for it. You saw the power of using IDAS for road design, especially for the intersections, creating the bell marks and stuff like that. I had a lot of good feedback from that, which was amazing. And today you're going to see how much more better it is, especially with working with pipe networks, in this case, stormwater design. So the first step, or generally what happens in consulting, is if you have a draftsperson, they normally would sketch some polylines for you, or if you're working in a big office, someone might share that data with you. And depending on the technologies that you use, you might not be able to convert the polylines, or you might need to trace them using a proper pipe network designing tool. In this case, with IDAS, you could actually convert those polylines to an actual stormwater network. right? So let's have a look at what we have put together. Now, just to give you some insight on the actual site, right? As you can see, I've created an elevation map or a heat map or level map, whatever you want to call it, and it denotes the slopes or the elevations based on a color, right? This can be done in Civil 3D, and with the Devotech templates, which we are using throughout this course or throughout this webinar series, you can see the styles are quite beautiful. You've got a lot of different, you can generate the tables that look quite nice and aerial text and so on, but you can see that the low point of the site is actually here. So when I do my design for stormwater, I'm going to make it such that the outfall is going to be there, right? So it goes with the flow. Also, when you are doing your design, you would like to also make the levels of the platform try and angle towards that, meaning make these portions a bit higher, which I have done. And then you would normally slope the road towards or against the NGL, the natural ground surface, to form a channel, like a V basically. So the water flows in from the road as well as the contributing area, and it will be channeled quite nicely. That's what you can see here. So when you apply your super elevation or your crossfall, you will see something of this effect where the site is sloping towards here, and we've got the road sloping in the opposite direction, so that the water drains and channels along this side quite nicely. So that will give you a bit of an understanding to the procedure that I applied here. You might see some faults as we go along. As you can see, I had to conjure this up quite quickly, being on the road quite a bit for these few months. But I didn't want to cancel, and I hope that the content is very useful. So let's jump in here and have a look at the model. So this is the levels elevation site that we have created, or the style. That is the table or associated to the colors. Of course, you can customize them to whatever you would like. And just to show you some of the great styles, like I've been showing you throughout this webinar series, with the Devotech template, look at the array of styles that you can select from. That is quite a comprehensive list. In this case, I'm going to use the slope arrows just to give you a feel of what is happening with the site. So exactly like how I had explained on the infographic earlier. So as you can see, we've got all of the arrows or the slope arrows displaying on the site. And if I had to zoom in, you will be able to see exactly what I had explained on the screen. So for example, let's narrow into maybe this portion here. There is my crossfall, right? Quite nice. It is coming down. I think this was the change in the image I showed you, 320. And there we are. You can see that this site is going to be sloping towards that area. Generally, if you are not creating a platform that is higher, you might have a bigger watershed or contributory area. That's where you could run a watershed. But in this case, I'm keeping it simple and just trimming it to the site that you're seeing currently. Okay, so now that you understand what is happening on this site, you'll now look at how we could convert these polylines to generate a stormwater network using IDAS in Civil 3D. So here we are. The blue lines that you're seeing are the polylines. Let's assume that I have received it from someone else. I didn't draw it. And you will see that if I do select the polylines, you cannot see where the vertices are exactly, meaning that if you have the lines crossing, that is not how our networks work. We would need a vertex at every intersecting point, like there. Now, how do you fix it? You don't have to manually go and check it. You could use the built-in functions that are in Map 3D. However, IDAS has put it in a really nice place under the Quick Actions toolbar. So if we go to Map Cleanup, what we are going to tell the software is to select those polylines and break them so that wherever they cross, it will insert a vertex. If you don't do this, you're going to get errors in your stormwater analysis, or you might get a lot of different errors, right? So all I'm going to do is I'm going to select it. You can see I've got a layer for it for my CAD elements or the polylines, And when I do hit next, I've got multiple options. These are normally used in GIS applications, but we can also apply it into Civil 3D because Map 3D is built into Civil 3D. So we'll give it a few seconds and you will see shortly when we go back to that area that that vertex has now been sorted out. So if I go and click that line, you can see now it has broken it, and this will be quite perfect for our design applications coming. Okay, so that is always a question we normally get from the users, what is a better way? Of course, that's the position of the outfall on the top there, and of course the red lines denoting the area that I could work in. Now, sometimes when someone draws a polyline, it might not be in the correct direction because they're just giving you a layout. Now, again, with the label sets or styles built into Analyse, it's quite simple to navigate this and see what the directions are. As you can see already, the pipe on the left-hand side is going in the wrong direction because I want it to go towards the outfall. Same with this line here, right? Now, if you had to do this manually, it's going to take you quite a lot of time, and the result would be you would rather just draw these polylines on your own. But there is a better way to fix this, right? And Analyse has a tool that will actually help you do it much more quicker, faster, and efficient. So if we go to the Analyse tab and we go to the Stormwater option, we can now go and select the wizard. Okay, you will see in a bit, right? So we can give it a name. So that will be Stormwater. Of course, you can always, if you have existing networks done, you can always analyze them and select them. You can select your parts list. Again, a very comprehensive part list. As you can see here, it has a lot of our South African catalogs. For this example, I'm going to be using Rockler, but you can see there's eThekwini, GRA, Tshwane. Yeah, there's a whole bunch of them that you can actually make use of. Okay, and same for the pipe networks. You've got Newtech, you've got Amco, Amanzi, Rockler. Again, I'm just going to stick with Rockler for this session. Okay, I can also filter the objects, so I just want to select the polylines for the storm in that layer. So I can just go and either just draw a window around it, or I could go and select an object to say that, hey, that is where it is going to be. And of course, I can pick my elevation or matching point. So I will use crown in this case. Okay, I could select the outfall location and set the flow directions, but I want to just leave that for now to demonstrate my point. And once you hit OK, this is the result. So if we zoom in, right, I think I should have used a lighter background here, sorry guys, but if we zoom in, you will see that the structures and the pipe networks have now been inserted. All right. If I go and select that structure, just to show you I am not bluffing you, you can see the contextual ribbon pops up. And I will just isolate everything so that you can see the extent of the pipe network that we are designing for storm water. Right? So it will take a few seconds, and here we are. And then I can zoom out and you will be able to see the actual extent of the pipe network, and that is the result. Of course, we can have our outfall there. We can go and edit a lot of the layouts. For example, at those center points, I might probably rather change them to inlets, but you will see that in a bit. All right, so that is the pipe network layout done in a few clicks, very, very quickly. Now, coming back to the problem that we normally, or the challenge that we normally face, we don't know or how to correct the direction of the pipes, especially if you are converting it from a polyline. How do you convert it in an efficient way? Now, Analyse has a really brilliant tool that, one, you could just regrade it, or you could regrade it as well as select the outfall so that it could also update the directions, called flow directions. So let me show you rather than talk a bit too much. So first of all, I'm going to put on the labels. Again, really, really great to find it in the template. Very easy. Again, a whole host of styles built into this template. I think it's about 1,800 if I'm correct. And you can see how easy it is actually labeled. So ease of use, or what we would call normally UI in programming or user interface, is quite nice. And you can assign it to different elements. In this case, I am going to be selecting the direction arrow. I'm going to apply it to the entire network. I do not want the structures to be labeled at this case. And when I click on just one element, it labels the entire pipe network. And as you can see, the directions are still incorrect, right? Because we just converted it to a pipe network. We could have fixed it, but I just wanted to emphasize my point and do it again. But this is what we have. Now that we have the network on, we have an idea of the direction. What can we do? Now, under the Storm button in the Analyse tab, you do have an option to regrade the network. Right, so I'll select my Storm network. It'll take a few seconds and you should see a very nice menu that pops up. Right, so you can specify your min and max cover if needed, your correct target surfaces. I mean, you've got a lot here depending on your site, where you would like to match it. I'm going to go for the crown. And of course, you can play around with these min and max slopes. I will just hit OK for now. And you will see it will tell you that no outfalls exist in this network. Right? That is because I have not swapped that structure at the end. It's still a manhole. So what I will do, I will use the swap structure command in Analyse. I will go to the catalogs that's built into the templates. I will scroll down and look at that. We have one called outfall. So we hit OK. I will just simply click on it, hit enter, and now you can see it has updated accordingly. So let's go and fire up that command again. So I will go to regrade network. I could have went directly to flow directions if I wanted to, but let me just show you the regrade first. Right, so if I go to Storm, right, I will get that menu popping up again. I will just update or toggle the surface to what I want it to be, and the match point or the match location, leave everything else as it is for now. And if I hit OK, we will give it a few seconds and it will generate. And if I zoom out, you should see that it has been regraded. However, the directions have not updated yet. Why? Because we did not tell the software where we want to force the gravitation towards. So I will go then and select flow directions. Of course, you could have came here directly rather than going to regrade, right? And I will go and select my outfall. So if you didn't swap the structure, you could have selected a structure even if it was a manhole, and the software would change it to an outfall location. Of course, I will also tick regrade pipe branches, so it will open up that menu once I select my outfall. So I will go here and select the outfall location, telling the software that the stormwater network needs to drain to that point. And again, I will just go and update the match locations. You see this menu popping up again. And if I hit OK, I'll give it a few seconds. And when I zoom out, here we are. Everything now is moving in the correct direction, as you can see here, right? It's all draining towards that outfall point, and I am very happy right now. So the reason why I've showed you doing it without the flow direction as well as with it, because sometimes the users say that it does not work. You would need to go and fix or select flow direction and then regrade it so that it will grade the pipes to flow in the direction towards the outfall. Now you can see the power of this already, especially if you are doing it manually. It can take forever. You might have to click every pipe. You might have to reverse the start and end structures. There's different ways people do it. To be quite honest, I would just draw the polylines myself in the correct direction to save me time. But of course, with Analyse, whether you receive those polylines from someone else, whether you do it yourself and you make a mistake, you can fix it quite with a few clicks. Right? So you can see the power of the software already. Now, when it comes to the long sections, you can also generate that using the pipe manager in Devotech Analyse. I'm using version 12, right? So let's have a look. So this is my site. And if I go to the IDAS Pipe Manager, it will open up the interface where the analytical engine or the analysis happens. Right? So I can toggle off certain data if I would like. I could go and toggle through the variety of different headings here. For example, we can go to profiles, you can see something's wrong there, I can go and fix it, it's quite visual. And there are a lot of functionalities that you can go and build off. Now, the great thing I like about it, there's a built-in help file. So if you are new to the process, or you're getting any errors, or you might need to find out further information on the analysis, getting a bit tongue-tied, sorry guys, on the analysis, all of that is detailed in that help file, and it's very, very easy to follow. Okay, so here we are. We've also got the top ribbon where we could customize quite a bit. Okay, we've got the profile views where you could go and select the start and end structure. You could grade your pipe, update your slopes. But what I want to do here is I want to go and create the profile views. So I will go and select that outfall quickly. Okay, and it will ask me for a reference point. And once I click, or all I can do is I can right click and select the insertion point, and I will get this ribbon. So I can start at the structure name, or I could actually call it or make it start at a number. I will just maybe, for example, say the base name is branch, just to be a bit different with that. Start number, so I want you to start at branch 1, branch 2, and so on. Right? Of course, there should be alignment, because I mean it is in an alignment, or you could say branch 1 alignment, something like that. You can select the correct target surface, very, very important. Okay, and once we do that, we can then also go and customize as to what label style or band set we will want to use. So first of all, it's the grids. So you can see again the long list of styles in the Devotech template for Civil 3D, and of course we can go and select the band set. Band set being the elevation data that's attached to the actual pipe network and so on. Okay, so once I do that, I can just hit update, and when I switch back to my Civil 3D, on the left hand side, you will see all of the pipe networks, long sections done and dusted. Simple, easy, very, very cool, and quite easy to understand. All right, so that is the long sections done with a few clicks. Now, of course, before you go and do that, it is good practice to go and label and swap your structures first, but I thought I will just keep it with the flow, right? So generally what we do is we would swap the structures first. We will rename them depending on whether it's a curb inlet, a manhole, junction, whatever type of pipe network you're doing, you give it uniformity, and then we would normally do the profile section. If you do the profile view first, that is fine. And that is what I've done here, because you can still go and swap the structure. So I have kind of swapped the process around a little bit, no pun intended, and you will see that you will come to the same result. So let's see how this works. So I'm just going to do it for a few sections in the model. Unfortunately, I didn't get to the entire model to swap everything. So I will just show you a few of them. As you can see, it's currently a manhole. That should be a curb inlet that you would need to position before a bell mount. And you can see again, you have a variety of parts or structures to select from using this template. So I'm going to use the Swan M1 for the right hand side of the road. And when I select the structure and I hit enter, you will see it updates accordingly. Right? You might see that there is a line that's attached to it. That line is based on the guidelines of the municipality, meaning that the inlet should be positioned within that range 4 to 5, right? So that is like where the sweet spot could be from the bell mount. So that ruler actually gives you an indication of relative positioning, which is absolutely great. You can also use it to check your road design if the low point is there based on your geometrics. Okay, so what I'll do is I'll just switch off the surface so that we can see things a bit clear. All right, so again, I can just go to the no display style in the Devotech template. hit OK. I think that looks much more better. And you can see I can now just simply align this to the edge of travelway or the edge of the lane. I could use the square grip to either move that towards it, like you will see now. So I'll select that. I will move the entire element to the position. So I'll just position it quite roughly right now. Okay, and I can also use the circular grip to rotate it. Okay, so you will just need to fiddle around a little bit here. That's not a train smash, it's basic AutoCAD, right? And you can see the rotate command is also there, so you can align it to your road edge. You could use a base point to help you get the reference and so on. So this can be done for multiple structures at one time, right? I've just done it for this one, but if I selected a lot of the inlets on the same side of the road, I could have swapped multiple at the same time. Let's look at here, right? So let's say there's going to be a low point at this structure, and I would go and swap it to a low point structure, simple as that. So I would go back here using the swap structures command in Analyse and select the low point structure, select that manhole, and I could change it. And there we are, right? So now we have put in a low point structure there, or catchment. So again, I can go and rotate it accordingly. Of course, you would want it aligned as good as possible relative to your road edge. It is a little tricky along a curve, but it is doable. It just takes a little bit of fiddling. But I will just position it relatively so you can see how easy it is to customize the positioning as well as swap these structures. And the great thing about this is it's intelligent, meaning that it has all of the metadata attached to it. Okay. Now that I have that, I will just probably rotate it the other way, and I will drag it down so that it sits quite nicely along that position. There we are. Okay. Now what I could also do is, maybe I don't want a structure so close to this. I can actually delete that structure using the delete structure command in Analyse. And it's going to ask me which pipe I want to keep. I will use the longer pipe, and with 2 clicks, I am done. Right? So it has joined the pipes to the relative structures as well as deleted it quite easily. So again, you could go and do multiple structures at the same time. And just to show you that you will need to rename the structures even though you swap them, because then it still works with that name tag. But that is quite easy. Like you could use curve inlet, and maybe if it was a branch, I don't know, 1, it's the second inlet in the branch, you could say KI 1.2, and that is it, right? There are better ways that you can rename it, and I will share with you some resources towards the end of the webinar. All right, let's go to the long section. Now, believe it or not, we can also swap structures in the vertical profile or the long section, and we can also grade it here. So I'm going to use the grade pipes option in Analyse, and I will select the start structure. I could end at a pipe as well, but I will just use the structure as well. And I will tell the software that what slope I would like it and where I would like it to match. I don't want a drop value. And you can see the current slope is that. If I wanted to use a slope of, let's say 1:500, you will see the entire pipe network has shifted along that point, right? That might have been quite not as steep as you would want it to be, or noticeable on the screen rather. So I will just do it again. I'll go through the commands, and what I would do here is I would use, let's say 200, and I hit enter. And now you can see clearly it has shifted from there to there. So it is quite a nice tool to grade multiple pipes at the same time. Now, how much of time that saves you? Because generally, yes, you could go and play around with the grips here. You have to make sure that your snaps are done correctly. I mean, if you've got a few pipes and you feel comfortable doing it this way, by all means you can, but you can see sometimes if you select the wrong grip, it kind of offsets. So you would just need to be a tad bit more focused when you're doing this, position it correctly, and of course you can adjust it like that. However, if you got the grade option, I think that is a much more of a time saver, much more controlled. Okay, we could also grade backwards. What do I mean? I could select that as the first structure, and I could select that as the end structure. So I'm going in the direction that I clicked. A lot of software can't do this, so you can see it already picked up a negative slope. We're going upwards because of what I had done, and if I type in -100, you can see the result on the top there from that portion. Okay, so you can grade in both directions. Again, it's a good time saver, especially if you have like a low point or something like that. You have a common draining point, it's quite cool to use. And if you wanted to fix the inverts, now as you can see, sometimes they might go above ground level also. Okay, I could adjust the cover if I wanted to, the sump depth and so on. And once I hit OK, actually under the adjust I chose to be below ground, but I will fix that quickly. Give it a few seconds and you will see it will adjust very, very shortly, right? So I will give it a few seconds. My computer is quite full, so there we go, there we are. And you can see it aligns or ties in perfectly. And if I carry on along the pipe network, that is the result. So instead of moving those manually for going either above the ground level or to below it, you could use the adjust inverts option to sort that out in a few clicks. Okay, right. You could also swap pipes. We've been dealing with structures currently. What if I wanted to swap a pipe? Now, IDAS has a swap pipe option, right? So let's say I'm going to use a very big pipe, let's say 1050, so that you can see it visually on the screen. I will select that pipe. I could select that pipe. Like I said, you can select multiple elements. So I will show it to you with the pipes. I hit enter, and you should see now the diameter has updated accordingly. And then of course I would just probably run the adjust inverts again, and it will fix the positioning of the structures. So you can see already the time that you would save, as well as the methodology applied when using the software, right? It is a really, really great scenario, a really, really great power-packed BIM application. I mean, IDAS has worked quite a bit on the development front, and you can see how intelligent it is for stormwater design. Of course, now we've been only dealing with the modeling. Like I said, I did not get a chance to update the entire network, so I didn't run the analysis on this network per se, but I will show you on one of the files that I've already done. Okay, so this was the site that we have. Okay, probably I will fix it when I get some time and give you a big recap or a preview before our next webinar. But this is what I had. This is another file that we switched to. I've got the flow paths that have been drawn to the curb inlets, meaning that what will the perceived flow of water, the longest path of water be? That is drawn using a polyline. You could also use the water drop analysis for this, and it will give you the perceived path of water by the point or from the point that you click. And as you can see, it takes in consideration the terrain, and you can see the slope arrows are spot on, and that flows directly into our curb inlet. So you would need a curb inlet for each catchment. A catchment will be the tributary area. You could run a watershed analysis for it and trace it out. I couldn't show that now because it will take a long time, but those lines that are in a light, like a pinkish color, those are my tributary areas per inlet. Now, if I switch to IDAS, right, this is the preview of it. And if I go to catchments, you will see these are also here. I can go and specify the runoff coefficient, the time of concentration, whether it's pervious, impervious, that type of scenario. Again, is based on the Sanral drainage book, that blue book. So all of this should be familiar with you. I could go and override it. I could auto select it if I do my design correctly. the software will actually pick up the inlet in a catchment for me without me going and clicking on it manually. We've also got different hydrology methods. So we've got rational, hydrograph, eposwim. We're going to be using rational. You could decide your TOC method between Kirby and Kirby. We've got built-in IDF graphs that you can go and have a look at. And of course, the ascending and resetting multipliers. So if I change that to 2, you will see that the triangle or the graph at the bottom updates. So it's a very, very detailed dashboard type of a scenario, right? You've got everything you want in front of you. Of course, you can go and customize the hydraulic parameters. So whether you want to use dynamic, steady, or kinematic, they are all built into the engine. You can set your analytic times, your durations, and so on. And of course, you've got these settings for the dynamic wave. And if I click Analyze, of course, you can see your minimum, maximum velocities, minimum inner diameters, all that in there. And if I hit OK, it will analyze it. If you do get any errors, those errors are detailed in the actual help file and how to fix them, or you might need to go and check your network. And as you can see, here is the report. Not only that, I can go and export or calculate my bill of materials based on SABS 1200. Right, so I hit a calculate. And when we do that, look at this. This is really cool. I mean, you could export a lot of things from the software. This is just one example of them. So I will hit export bill of materials. Right. It will pop up asking me to give it a name. I will just call it BOM, bill of materials, literally. Okay, so here we are. I will just drop it on my desktop. And if I open up that Excel file, so I'll just go to that same file that I've done. Here we are. You've got all of that data exported to a nice Excel sheet. Pretty cool. Very, very nice. Okay. So you can see the automation as well as the intelligence that IDAS affords you with Civil 3D. Of course, I can go and toggle or play around with a lot of these. For example, I can go and see which pipes are violating. For example, the inner diameter, I can go and apply a pipe minimum sizing. I don't think it will work correctly because I did not update the network correctly. Okay, it did complete, but you could go and set your minimum inner diameter on the top ribbon here. Okay, so you can go and set it there, and based on that, it will flag it at the bottom here. Okay, so again, that is inner diameter, not nominal. Big difference, right? Okay, that is the preview of the long section. You could go and click on a branch. It also highlights in the plan view. And I can go and also grade it or adjust the elevations in this platform. However, if you are not familiar with it, make reference to the help file, or you could export it again to Civil 3Ds as the profile views and adjust it there. Whichever one you are comfortable with, you could make use of. All right. So that is what I would have done with my site. I would label the curve inlets, added the flow paths, run the analysis, and I would have came to the same thing. Again, you can see this is the preview of the IDAS help file on the different networks. You see we've got one for storm and sewer, and then you could literally scroll around and it guides you through taking this forward. So it's quite easy to apply with a really, really good step-by-step help file. If you would like to explore especially stormwater or other pipe networks in detail, you could head into the Devotech website, which has some fantastic videos done by Antonin. You will simply go to devotechgroup.com, and of course you would go to training on demand, and you will see there is a heading for stormwater videos, and look at the immense detail. That's why I had to fly through this very, very quickly, because I mean, we would have not gotten to not even a quarter of that in this time, right? But you can see everything is defined and explained step by step. There are other videos that you could make reference to. These are all freely available on their website, and you could go and upskill yourself. I also did a webinar series on this on our Baker Baines YouTube channel. It was titled Intelligent Stormwater Design. It was done on the previous IDAS interface, but the methodology is exactly the same. I broke it down into 3 parts so you could go have a look at it, and it goes through it quite nicely. So you have enough resources to play around, and of course you could always reach out to me if you have any further questions. So that is it from me today. Let's look at our closing takeaways, and I can let you get on with your Friday. First of all, you had seen how amazing it is to convert the polylines to a pipe network in a few clicks. Not only that, we used our South African catalogs in there, plus it grades it accordingly, not erratically below the surface or above the surface. It uses a lot of intelligence with it. And of course, we use some GIS functionality built into Civil 3D or Map 3D to break those vertices. We then looked at how you could check the flow direction. We had a group of polylines that were drawn in the opposite direction to the outfall location. We assigned labels using the Devotech template, again, very, very clearly labeled, again, upon there. Okay, so very easy to use. Once we did that, we checked the flow or updated or regraded the pipe network, but it did not update the direction because we did not specify as to which point it needs to drain. So what it did was it simply graded it based on the cover, but not the direction. Thereafter, we used the flow direction. So best practice would be to go to the flow direction directly, select your outfall location where you want your network to outfall to, and then thereafter, make sure you select or tick the regrade pipes option. It'll open up the menu where you could set your cover values for minimum and maximum. You could also set your match location, whether you want it to be at the crown or invert, and so on. Check your slopes, hit OK, and then we created our pipe network that not only was intelligently graded, but it was all diverted or channeled towards our outfall location. That is quite a time saver right there. Thereafter, you saw how easy it was to actually create the long sections simply by going into the pipe manager in the Analyse tab. You see it opens up a different window that you could work on a separate screen, get your analytics together. And then, of course, you could also preview a lot of the different options that were built into it. And then you could simply go to the Civil 3D tab and output it, the profile views, to Civil 3D, and you have your long sections done and dusted. We thereafter explored various options as to editing the pipe network, where we swapped various structures. I showed you the curb inlets that would be normally used before a bell mount based on the standard spacing or edge distance with that ruler that was there. So it went up to, I think, 6 or 7 meters. Okay, so it helps you with, from a geometrics and stormwater design perspective, to position your structures correctly per spec. I also showed you how you could swap another structure to a low point where a common draining point will be prevalent. And of course, we also swapped multiple pipes. So we regraded them in both directions, backwards and forwards. We renamed a few structures to curb inlets. We did quite a bit in this short time. But at the end of the day, you saw the versatility that IDES affords you when you use it with Civil 3D. And last but not least, unfortunately, I couldn't do it on this side, so I do apologize. It has been quite a chock-a-block of time on my end. But maybe in the next one, I will just give you a quick preview of what it looked like. But what you would need to do is label your stuff correctly, swap your inlets, draw your catchments in, and then just follow what you would need to do by selecting the flow paths, the catchments, specifying your coefficients, your time of concentrations, the same thing that you would normally do on an Excel sheet where you would conjugate. However, this is much, much more better and much more efficient. Okay, so with that, I will just give you a quick snapshot on how we could help you very, very quickly, and then we could take some questions if there are any. So here at Baker Baines, we solve our customers' problems through digital transformation, helping them to design and make a better world. And I'm sure you all can agree, all of my webinars are tailored towards us in South Africa. I don't use a site in Europe. I don't use generic data sets. I literally create them, so it takes me a really long time sometimes to get these together. So there are three methods that we could help you with, or three ways. First of all, you could do it yourself. We have CAD Learning, where you could purchase the online portal and have access to it on a yearly basis, and it has a variety of software on there. Civil 3D is on there, Revit's on there, InfraWorks is on there, vehicle tracking, robot is on there. There is a lot of Autodesk applications that you can learn on the go or on a project basis. So you could do it yourself. You could also let us show you. We have a variety of training courses that we provide, including IDAS, as well as in terms of video content. I mean, you could literally go directly to the Devotech website and access those great content and learn on the go as well. So we provide for Civil 3D, InfraWorks, Revit, InfraWorks, Civil 3D, and AutoCAD. I'm currently CPD accredited with SciC, so it's also really a nice thing that you could get onto your IPDs or stuff like that that you're doing. And of course, we do apply or offer customized training on Kickstarters based on your proficiency level. And then of course, the option that I really do enjoy the most is doing it together, where we would partner together on a project, train you on that project, do it together, and your work as well as your learning curve gets ticked off at the same time. So if you are interested in any one of these, you're more than welcome to reach out to me. Right? We build this on our IDOT methodology, where we assess your current situation, we educate you to fish for yourself, but if it is above your depth for any reason, we are here to consult for you. Of course, you can follow us on our various handles. We're on LinkedIn, Facebook, Twitter, Instagram, and YouTube. Of course, this webinar recording will be uploaded to YouTube by the course of next week sometime, so you can always revisit it. I will also reshare it on LinkedIn so that you could also tag your buddies that could have not made it here today. And of course, to our clients, we offer a support desk that's open from 8 to that time, and of course, support@bakerbenz.com. And last but not least, if you want to reach out to me directly for anything civil infrastructure design or scan to BIM, you're more than welcome to follow me on LinkedIn and connect to me on LinkedIn. My email address, I think most of you on this list already have it, but you could jot it down quickly. It's shoaib@bakerbenz.com. Those are the technologies that I delve in quite a bit and what I can help you with on the screen. So with that, I will open it up to Q&A. So please, if you do have anything, please drop it into the chat box. I will be very, very curious as to see what you would like, or even your comments. What did you think of the actual webinar? It'll be really, really appreciated. So I'll give it a few minutes to see if there are any questions. Okay, let me just take a quick scroll here. Wow, today is no questions, which is quite interesting. Normally we have a ton of questions. I think year-end is kind of catching up with everyone, which is fine. I totally understand. I'm also feeling it a bit. So with that, I'm not gonna keep you guys any more longer or pull any time. Of course, if you want to reach out to me, you're more than welcome to. If you have any questions later on, you can also reach out to us. But thank you very much for attending today's webinar. This will be probably the last webinar I do for this year, 2021. So until then, I wish you all a great new year, prosperity, and I look forward to connecting with all of you in the near future in 2022. Have a great Friday and keep well, everyone.